get started right away. Brilliant. Easy, right?
Thank you for that wonderful introduction, Edward. So I'm Rob Sanderson, Senior Director for Digital Cultural Heritage at Yale University, and this is Kelly Davis, the Cultural Heritage Data Engineer who works with me. So we're going to talk today about our reconciliation process for knowledge in LUX. So you've heard the word LUX already. It's not an acronym, by the way. It is just the first word in our motto for the university, LUX et Veritas, Light and Truth. So what is LUX? We think of LUX as a groundbreaking discovery and research platform that provides unified access to all of the collections of our museums, libraries, and archives at Yale. You can see the numbers there. We have 17 million objects, not as many as the Smithsonian by a long stretch, but still a significant number. But we also have 5.5 million people in the knowledge graph, 4.5 million concepts, 13 million works, for a total of about 42 million records. If we were to turn all of those into triples, right, it's a knowledge graph, it's about 2.7 billion triples. If we were to materialize all of the relationships, it's about 3.5 billion triples. But the two words that I want to focus on are unified, what do we mean by that, and collections. What are the collections? So for unified, we think of it in three ways. And the first is that there should be one record for each entity that we have in the graph, rather than one record per source database. So we have here, the record for the Rijksmuseum. We have our own identifier, we have our internal records, and then we have reconciled the Rijksmuseum with external data as well. Through that reconciliation process, with the external vocabularies, we can then enrich our knowledge. So here we have names in different languages, in Chinese and Japanese and Arabic, additional names, non-preferred terms, the dates, the places, and so on. We maintain normally only a very small record, right? The name and some identifiers. All of that in the LUX interface is generated from external data that we at Yale do not manage directly. And finally, it should be connected, right? It's a graph. So in the interface, you can see these across the top of not just here is the information about the Rijksmuseum, but which works, which objects, what are the works about the Rijksmuseum, and so forth. Then collections, we have 6 primary collections that are present in LUX. The Peabody Museum of Natural History, the Yale Center for British Art, the University Art Gallery, the Beinecke and the Yale Library. The next one is not a picture of a thing because it is a collection of blank photographic paper, which doesn't make for a particularly interesting image. So this is a rendition of the different types of paper in that collection. And the School of Music is also working with us. So they have a collection of more than 1,000 musical instruments that you can see there in the bottom. So for LUX, we had some requirements. No new system of record, right? We are not going to produce yet another place that would need to be synchronized back and forth. It's just a discovery layer using the knowledge graph. No new army of catalogers, unfortunately, right? We would love to be able to enrich by hand everything, but no, it all needs to be automated. So everything needs to be as performant and accurate as possible without a human in the loop. No cross-searching, right? Everyone has their own different data models, their own conceptual models, their own interfaces, their own query languages, plus the fact that when you make a query, you always have to wait for the network. So everything is reconciled and connected up front rather than at the fly. And finally, it can't take months and months and months just to rebuild the data set. It needs to be done in less than a day, which we have managed to do. So it's very easily parallelized. So here is our data architecture. If you put your head on the side slightly, it looks like Eno's architecture from the first day. I don't recommend actually trying to do this, but if you turn your head upside down, it looks like Chris's architecture. So The first step in the architecture is harvesting, which I'll talk about, and then I'll hand over to Kelly to talk about the rest. So we have all of the sources internally, then more than 20 external sources. We collect the records from those sources to be put into the reconciliation pipeline. We use the AAAF Change Discovery API, which is also called activity streams. We do not go through the AAAF manifest. Instead, we just have a stream that talks directly about the records themselves. We also, for the library, have an S3 dump of everything, which is they have about 30 of the 42 million records. For the external sources, we use APIs, we use dump files. For the Getty, thank you, David and all, we use the change discovery mechanism. Basically, we do whatever it takes to get the data into the system as efficiently as possible. And with that, I'll hand over to Kelly to talk about transformation and reconciliation.
Thank you. Thank you, Rob. Great. So now that we have all this data available to us locally in our caches, we have linked data, but it might not be in a format or a friendly ontology for Lux. So we do have a little bit of a transformation or mapping process at this point. We're looking for JSON as our serialization. We're looking for linked Dart as our ontology. So for the internal records from Yale, they are coming to us already in this format. We might need to do some minor work. But for a lot of our external sources, there can be quite considerable scripts at this point to transform everything into linked Dart and to JSON. So post-transformation, we would start to begin our reconciliation process. And Lux addresses the challenge of having multiple records, each with their own URI, but then they're describing the same entity. So on the screen, we have a number of different identifiers that are all talking about the Rijksmuseum. Ideally, during reconciliation, the Lux pipeline is going to find all of these URIs talking about the Rijksmuseum. It's going to bring them all together and create that one record that we've been using as the example. So this is obviously a very straightforward thing for me to say, but as anyone who's done this knows, there's quite a lot of challenges with this work, not the least being that there is an ontological and worldview difference between different models. So the concept of what an entity even is will vary by worldview. So to use museum as an example, the 2022 definition from ICOM would probably translate into a link.art group class. But Wikidata, which is a major source of linked open data and cultural heritage, might have different properties on their record, one singular record, that would describe it in linked art as a group. If it's classified as an organization, for example, they might classify it as a facility, which to linked art would make it a place. They might have properties that include an architect, which in linked art would make it an object. They might have properties like the objects in the collection, which in linked art would make it a collection set. But linked art does address this complexity by making it possible to create actually 4 separate records depending on how the entity is being referenced. So to accommodate these different worldviews, Lux will extract relevant information from each record and create a separate record for each class and maintain unique identity by appending this #qua class to each external URI. So that way we can process this single record for the Rijksmuseum from Wikidata into a group, a qua group or a qua place as necessary based on how it's being referenced. So I'm going to walk through the reconciliation workflow here. So once we've settled some of the ontological concerns, we move into our script for reconciliation. There are 2 ways that the Lux pipeline will perform reconciliation. Primarily and sort of preferred would be via URI. So during that transform process, we've mapped any other ontologies that describe a same as relationship into the link.art property for equivalent. And the reconciliation will start with our internal records, but process a record by record, each at a time looking for URIs in this linked art equivalence property. So when it finds one, it's going to check to see if it's not processed it before, and if it hasn't, it will go to the record cache for that source. It will then look at the equivalent property there. It will add that back in. It will sort of loop around this process as many times as necessary until it reaches a point where it's seen all of the potential matches that it could find. If at that point it's more than 3 URIs that it's collected, which is an arbitrary number, but where we've decided to draw our kind of domain, it will say it's reached success on this record. It's going to move out of the process and move into the next record. But if it has not, If it has not done that, it will attempt a primary name reconciliation against some name indexes that we've built from the Library of Congress and the Getty vocabularies. At this point, there's no AI built into that process. We're always looking to improve it. We do minimal kind of intervention in the primary name string to try to force a match, but we are iterating on different solutions. If we do get a match here to one of the name indexes, it's actually going to go back through the URI process again, so really privileging the URI until it reaches the 3 number and hits success, or it fails and it moves on to the next record. So after reconciliation, but primary to the merging process, the Lux pipeline will re-identify all of the URIs and for each record, and then all of the URIs that are referenced within each record. We're going to re-identify that to a Lux URI. This makes it much easier for us to compare connections and to kind of deduplicate processes. Then we move into the merging process, where we want to take all of that accumulated knowledge from those various connected records and make choices about what's going to go into that singular Lux record. So as Rob was mentioning, we really aim to integrate as much information as possible for our singular, for example, Rijksmuseum record. On the left, you'll see that's everything that's coming from Yale. So we have 2 library records and 1 Paul Mellon Center record, but all they're providing to us is a name, pretty much the same name. But because we're able to reconcile them and then merge them, we end up building a much more descriptive record based on all of our various sources. And this is not actually even all of them, this is just a selection. When merging and reconciliation is complete, we do a little bit of final cleanup and prepare the data for ingestion into our backend database, which is called MarkLogic. That's where we extract some key triples for indexing in Lux. And then an export script will generate 24 very large JSON files, which are stored on disk.
Thank you. So, lessons learned, and I have 8 minutes, so I can go into some great detail if you want. So first of all, we found through this process that the cultural heritage data in the global knowledge graph is actually very well connected, right? Libraries, museums, and archives have used Wikidata, have used, the Library of Congress has reconciled with OCLC, VF, and FAST, ULAN, of course, and so on and so forth, right? There was a large network of existing human, or perhaps human-scripted, equivalences that we are leveraging. Wikidata, love it or hate it, it does have a lot of equivalences. So we can use it, even if we don't trust the data of all of the descriptive content, we can at least use it as a hub for identification. So here's a slightly challenging one. The libraries, at least before Lux at Yale, seem to be better at connecting their data than the museums, right? The museums used ULAN and AAT, but they didn't have the URIs. Right? They just used the string. Whereas, at least in our library, they had direct URI references for LCSH and Library of Congress Name Authority file. So taking those two together, please, please, please connect your records, connect your knowledge to some external data source. Doesn't matter really which one. If you don't have a preference, then use the Getty vocabularies. But anywhere in that graph, anywhere in those connections would allow systems like Lux, and perhaps like your own, to be able to crawl that connection to find all of the equivalences to build that enriched record. No collusion occurred with this slide from the first day, right? So no one has clean data, and that's okay, right? Everyone is going to have to process things. Everyone has a slightly different understanding of the world. So long as it's fair, so long as it's loud, we can process it, we can add information to it, and we can write reasonably coherent, consistent code to deal with it. As a community, of course, we can work together on improving the situation for our own data sets to make it easier to build those cross-collection connections. And finally, as we've all seen over the last year and a half, clean data is so essential for doing anything with AI, right? AI already hallucinates with clean data. With messy data, it's even worse because it thinks it's doing the right thing. This is perhaps preaching to the train of monks, but everyone has a different data model. That's less okay, right? It's very hard to computationally determine and clean semantics compared to individual strings and numbers. As a community, of course, we need to adopt standards. I'm sure there's no debate there. But again, particularly around the AI notion as well, clean semantics of what a particular property means is much more important than clean data. We can clean data with code, but no machine is ever going to understand that you are using a property slightly differently, or perhaps very differently from what its scope notes and definition says. And then reconciliation is hard. We spend about 14 hours of a very, very large machine in AWS doing that reconciliation process. It's computationally expensive. It uses about 4 terabytes of disk space to build everything. But the end result, as you hopefully have seen in Lux, is worth it, because then once we've reconciled the information, we can use the knowledge of other organizations, such as your own, to improve our records. Right? And once all of our data is public, you can use our records to improve your records as well. Though, there are some trade-offs, of course. Everything is automated, but everything being automated means there's no human in the loop to catch stupid mistakes that algorithms always make. So we try to optimize for false negatives rather than false positives, right? So a false negative is when there are 2 records that should have been merged together, but they don't get merged, so it's a missed opportunity. Compared to a false positive, where there are 2 records that are actually about different things, but the algorithm thinks they're the same thing, so they get merged together. It's much harder to split them apart later, not only because we've already assigned one identifier to that thing when there really should have been 2. Again, no one has all the information, but together we do. Right? If we all work somewhat on little parts of this problem, if we all link from our system to one other system, and they link to one other system, we still get a graph. We still get a network that we can crawl and use to improve those algorithms for reconciliation. And finally, of course, enrichment improves the discovery, the research, the teaching and learning. As a university, these are, of course, our core stakeholders on faculty and so on. It improves the engagement for end users as well, outside of the university. People who see a record that just has a name and maybe a type, boring, right? But with images, with descriptions, with additional names in their own languages that they can understand, it makes it a much more enriching, rewarding experience for them. And finally, of course, that additional knowledge brings us closer to being AI ready, to use the knowledge graph to power language models for research, for learning, for discovery, and so on. So we didn't put the URIs in the first screen, so that now you've had to pay attention to the talk rather than playing with the code or playing with the system. But if you would like to play with Lux and you haven't already, Lux Collections Yale.edu. It uses linked art, which has been mentioned a lot, so I don't even need to tell you that URL. All of our code is open source, with the exception of the core MarkLogic product, which is proprietary. You can get every line of code that Kelly and I have talked about today from GitHub in Project Lux. Thank you so much.
Thank you, Rob. It's quite difficult to follow up on such a big project, but I will try to go from completely another perspective and try to talk to you about data in this case and what I want to do with them. So this overall idea starts from the fact that I wanted to actually analyze artistic circulation. What's the best way to analyze artistic circulation if you're looking at data is to analyze exhibition. We can see from the exhibition a lot of information we can extract. Who participated in where, who was where, who participated where, who was participating with who, when. In some different type of catalog, we may see more information such as address. So, in my case, specifically, I wanted to talk about 19th and 20th century development of exhibition, which is extremely important for art history. Some would say that exhibition made art history, and not only this claim. But how can we study that? Where we can find this exhibition? How we can put them together? How can we analyze them? So first of all, by looking at the data that we find from exhibitions that are coming from museum and not only, we can extract, for example, just to give you a few examples, who live we do. This is a list of people that live together in Paris, for example. But as you see, there is some address which are used more than others. We can assign to that maybe the temporal space and try to analyze who lived together when, which artist was together in the same building or share the same address of someone else. And that's allowed to study and do a better close reading of the source. We can use the same type of data to analyze where people that participated in exhibition come from, and therefore see how the address community change in Paris through the time and go more and more to our Montparnasse. But these are just examples. Another one that we can see, it is easy to do, is try to understand, for example, the internationality of the artist. Who was exhibit where, and for how much time? We can put this in a scatter plot and try to analyze how many locations are assigned to each artist, how many, where the catalog put them, etc., etc. Doing this with one source of data is, of course, one thing, but when we start to add source of data together, in this case is MoMA and Bazart, which is a collaborative database of exhibition catalog, we can try to check for each artist where in our data where he was present, and see, for example, certain type of French artists are more present in French catalog. I know because I know Bazart, while the more impressionist one are definitely more present in MoMA. And this allows us to understand maybe also how the canon of the art history is created. So this is what I want to do with the data. I want to build things like that. But there is a big problem. We have tons of data about exhibition, and they're all in different format. Well, I would like to have more, of course, but we have some data about exhibition, and they're all in different format. And I'm not talking only technical format, also conceptual. We have the Art Institute in Chicago, there's some API, there's JSON. The MoMA index, exhibition index on GitHub, that's a CSV. We have the Musée d'Art et d'Histoire in Geneva, which is producing the data inside of CRM, so shout out to Dominic Remondino here in the room. We have the Atlas Bazart, which we are actually working together to transform it in CRM, but we have many others. Now, all of these come, of course, with different conceptualization, different format, different type of information. So how we can put them together. So first of all, we need to define what exists out there. There are two different types of exhibition data. Generally speaking, we have the catalog. These are generally treated by historian. So catalographic information, they've been published for the public, general public, and they present a series of information which may be a bit of interest. And sorry, PowerPoint just make a bit of a mess. My love for Keynote is strong, but we can find who has been exhibited, when, where, for example. But this is fantastic. We can also find what exactly has been exhibited, and we have some biographical information. This is an example of the Salon des Indépendants, if I remember correctly. But sometimes there is a bio. Sometimes in certain Brazilian catalog, it's like, who doesn't know this person? His friend we do. So a bit of social information. And we have also the address at the time of the exhibition. Really, really a lot of information. But again, this is done for the public. We want to tell the public, you want something from this person, that's where you need to go and contact him. Go buy this thing. Then we have another type of source of data, which are more coming from database. These are more produced for the museum, or from the museum, and for the museum. They are internal data and functional most of the time. We may found this set of information, but we may also found a lot more. For example, who give me an object? So where this object come from? When I need to give it back? Quite important. Who didn't give me an object? So failed loan. I asked for a loan. They didn't give me the object. I want to record that. I want to see actually who's giving me this thing in time. So we have a lot more information, but again, for internal part. So if we take a look at these two data, and we want to bring upon some proper scaled analysis of exhibition information, we may probably need to deal with this 7 pattern. And that are somehow present in the majority of the data that I put my hands on. And I'm going to go through them one by one, but mostly the important thing is like we need to describe this thing. We need to describe object and event, participation, etc. How can we describe it? How we can create a conceptual model for it? Well, of course, we can use CIDOC CRM. Here I'm going to present CIDOC CRM modeling, but of course, this is not the only one. I'm using this because it's mostly used by cultural institutions. There is other model that may be worth taking a look at. Dolce is one of them. There is Faro, there is Event Model F, there is BFO. But okay, let's stick with CRM. It's greatly documented. It worked very well. So let's start from what we are describing. What is the object here? We want to talk about exhibition. Exhibition occur in time. They are perdurant, ontologically speaking, but their identity is framed in time. This can very well, counting that CIDOC CRM is an event-based activity, so an event-based ontology, so we can actually start to describe it as an activity and start to add pattern to that. So let's start from the object. What we want to say, first of all, is that there is something that has been exhibited. And I'm sorry if I go through this that most of people may know, but the idea of this presentation is that you can download it at the end and follow up the thing and do it yourself. But so we may want to exhibit something. That something may be tangible, that something may be digital, or maybe we want to express that in exhibition there was a performance part. And we also can express some role about each of the objects. But then what we want to go through it, temporal duration, what we want to express about an exhibition is really when it happened. We say it's frame in time. We talked about before about reconciliation and data curation. This is when the problem comes from, how to express the time, how to express time properly, how to express a ISO time, etc. I'm not going to jump into the wagon right now because it's going to take me 15 minutes for it, but just telling you that CIDOC CRM allows us for very flexible time expression. We can define that something is more precise or imprecise. And we also can define relative time. If we don't have time information, we can define that an exhibition come before another, or just after another. We don't know where exactly, but it's before this one. So, of course, there is also the spatial extension. We want to know where exactly this exhibition took place. Here we can express it in a very different way, but let's say we want to just add a city. A lot of time we have an address. A lot of other time we have a room. I mean, the pattern is still the same. It's still we are defining a place, and then we are defining with some coordinate of the place. And then I will leave like every museum have its own thesaurus system that allow them to put things together and say that the room is part of this other room that is part of the museum, or that the city is part of the other one. And each of us depend mostly on national institution for it. So there are other parts. These are simple exhibitions, but there are the more complex ones. More complex, I'm talking about Biennale of Venice, for example, where we have pavilion. In this case, this is kind of an important information, who is where during this kind of exhibition, because how much space is dedicated to each of them can simply tell us a bit more about the power, can tell us more about whose friend we do. But I didn't model this as I couldn't find any data. If you have it, please let me know. But in case you want to model it yourself, Anaïs Guilhem did a lot of work about topological relationship inside of CRM, which will be useful in this case. She did it for archaeology, so look her up. And she presented a paper just 2 weeks ago on it. Now then, also what we have is the knowledge source I talk about. Of course, the historical source. You cannot give data to an historian without telling the source. So that's pretty easy to attach to it. That's not a problem. Now, let's come to a bit more problematic, methodological structure. So we want to say that an exhibition existed in one place. Great. Now, a lot of exhibitions are traveling exhibitions. So we have multiple cities associated with them. Now we can define different layers of documentation in this case, which is always very useful. We may define simply that there are multiple cities associated with an exhibition. And of course, that's fine. You don't need to go into details. But if you have the details, please tell there are like different temporal segments. With CIDOC CRM, for as much as it doesn't have the concept of phase, we can say that there are different subtemporal segments of an exhibition, each of them connected maybe with a specific time span. So we can say that one part was in one place, another part was in another place at different time. This allows us to compute it in a map. Of course, then we can say that certain artwork were actually part only of the initial exhibition, and of course they were not in the second traveling one. So that's also, of course, possible. And more important is, for an historian perspective, is actually how to model this. So we do have exhibition, we know the artist. There is not only the artist that participate in exhibition, there is a structure of power behind it. So we have some director, some organizer, some curator. If you look at the MoMA data, you look who are the artists, who is the curator in the press release, which is somehow different, okay. But also who arranged the exhibition in itself, whose financing we may find in other places. These are all things that are extremely important if they can be extracted. And how can we model them? Like, I mean, this is a bit controversial in the sense that we can model as part of the major exhibition activity, or if we want, we can define another class, which is a management one. And in this case, how can we express the relationship between the two? We have the causal relationship. Something enables something else. Of course, the management are all the activity pre the exhibition. They may last also during, and they want to say who was part of that management that brought in the exhibition. Well, in this case, we do have two major properties of CRM, which is P17 and P20. In case of P20 that we are using here is mostly defining as a temporal segment that had the management a specific purpose to create the exhibition, but there is no strong causal relationship. We may probably better to look somewhere else for it, and this could be a nice inspiration. Faro is an ontology which is published in I think last year, which take a look at exactly this type of relationship. And we can say the cause, what enables something, what prevents something, extremely important, or does not prevent the success of the exhibition, or what's the intended cause. This, of course, there are other, the causal pattern that allow us to, which are develop as part of Dolce, which allow us to define better causal relationship. What I'm saying is, for as much as I can model with CRM, something else is out there, they can give me better details, is worth to look at. There is also the problem of participation. Now, of course, we want to say that someone participates. That seems pretty easy if someone is part of the management. So we can say that someone participates. So we have an agentive that is carried out, or someone participates to the event. But also here, we may probably be better to expand. We can say in a specific role which participated, but this is not the semantic embedded in the relationship. It's given in external vocabulary, which is bad. Now, other ontology allow us to define way more granular data for it. Normally, BFO is someone that initiates an occurrence, influence, facilitate, mediate, hydrons. Dolce is a concept of constant participation for the full one, of temporal participation. I know I can manage to have sub-activity and sub-activity in CRM and define it, but I really don't want to create multiple sub-activity to define something such as the initiation of an activity, if I can have a property for it, but maybe I'm lazy. There are many other more characteristics that we can talk about, specifically the spatiotemporal one, which is how I model the address, and I show you in the map before, and I do not have full time to go through that, but we can use the concept of space-time, which is incredible in CRM, in order to define that. There are also, in this case, other possibilities for the ontology, or we can use some other form of reification, but we can define that the address of someone as a specific time was, so at a time span, was, I don't know, in Rue Athénée in Geneva. Now, This, of course, we need to take into account that streets change over time, and they change name. They may change part. If I look at Paris, I'm looking at streets that were part of Belleville. Now Belleville is part of Paris, and of course they change everything in my data. And also here is a problem of curation, is a problem of modeling in time. And what we have is a lot of triple, a lot of that. So that may be. Not saying that you should do it, because this complicates things for the user and for everyone else, but it may be useful for people who want to actually take out the data and do spatiotemporal analysis. So we have a lot of this, and we actually, if we take a look at the major core, is mostly that. This can be applied to many, the majority, I believe, of case study. So the majority of museum data, we can have a very basic model here that we can link each exhibition with a place, with a type, with a person, with some object, and defining the role in CRM. This is somehow work without having to jump in on the spatiotemporal wagon. And this is the model that I actually start to work with for getting data together. But I was working more and more for another project, which is Bazart. Bazart is a project captained by Beatrice Joye-Prunel, which is a collaborative database for exhibition documentation, where actually multiple art historical researchers can add exhibition information. The great thing is that it's a global project. We want to take a look not just purely at the US or just purely at France, but a lot more of what it will be the North Atlantic. And we actually start to implement the project, and we have the data. As you see, those analyses come from here. So the data are there, they're in my computer. We do have a little bit of trouble in the academic setting to actually set up a knowledge graph, set up something that may last 5 to 10 years and not 1 year, and set up actually something that can be apparently accessible from the external user, which is not a given, because IT developers are very much afraid of everyone assessing it and making things explode. But we are going there, and we hope to actually put it out there very, very soon. So what can be taken out of this? So sorry for this very text-rich slide. So first of all, again, my main point is give me data. Like, I'm sorry to say it in a very wrong way, but please put your data. It doesn't have to be perfect. It doesn't have to be spatiotemporal model. It doesn't have to be modeled at a certain point. Just put it out there. If you can, you have a model here. There are tons of patterns. You don't want to follow this, follow linked art, follow the semantic reference data model. There are many things, but you can follow up, model your data, put them out there, and make them available. You cannot do that because of capacity. Put the data in CSV, put the data in JSON, put the data in Excel. Researchers are very flexible. We are used to deal with the very, very dirty data. You have absolutely no idea what I had to deal with in my life. But please put them out there. We don't shame anyone. So first thing, put data out there. Another thing, if you want to model it, it's quite easy. As you saw, no problem there. If you want to make someone use them, you can decide to have the spatiotemporal pattern. No problem, talk with a researcher, talk with me, we're going to find a solution. But what is clear out of that is that if we do that, we increase very much the chance to study art history and museum. We can create great analysis about what is the canon and how the canon is built. You saw with the example I show you just with MoMA and Bazart, how much the increase in percentage that we have of information. If we continue to add that, it's gonna be great, and it's gonna give us a proper perspective that can allow researchers to do close reading of the source. And indeed, what else I do? I read. I don't remember. Okay, well, I think that is it. But again, adding to that, I underline, if you don't have any curated data, no problem. Just give to me. Thank you very much.
So hello, good afternoon. My name is Kevin Page, and I'm from the University of Oxford eResearch Centre. I'm going to be taking you through a project we've recently completed, and to which many people from across the institutions represented on this slide have made many wonderful contributions. The project's called Enriching Exhibition Stories, and it's funded by the UK's Arts and Humanities Research Council. I'd like to spend most of my time telling you about the interesting things we've done with some software that we've contributed here. But first of all, I'll briefly explain how we combine two technologies to create the tool which then enabled those activities, which, as you can probably guess from the title slides, is a little bit different to what we've just seen. So the first of those technologies is linked art, which many of you will be familiar with, and which you've certainly seen in action several times this week, not least from earlier in this session. While there are many very impressive and large-scale applications and motivations for linked art, in this project we've wanted to explore an altogether simpler use, which is simply to be able to automatically reuse data about museum objects provided by a linked art API to save some time and labor of copying that information manually. The second technology we used in this project is the Quire publishing platform, which is written and open sourced by our friends at the Getty. And Quire has already been used extensively to publish museum catalogues, both in the form of easy-to-maintain websites, but also as PDFs and ebooks. Behind the scenes, a Quire project is created using standard encodings such as Markdown and YAML, which is converted through a software workflow. And that workflow, I think really interestingly for us, reflects the realities of document publishing as it is. That significant effort goes into an editing process, and we should reflect on that before assuming that cranking out a new version of something is cheap or even desirable. There's a lot of effort that goes into publishing a version. In this project, we wanted to explore whether we could expand Quire into some new situations and put it into the hands of some rather different users. So the first thing we did in the project was to create an extension, which you can see in action here. This extension takes a linked art URI, and it then goes and automatically downloads object data and images, converting them into Quire's internal project formats. The software was developed by my colleague Tyler Bonnet at the University of Oxford eResearch Centre. Adding this linked art doesn't mean those objects are automatically added to the Quire publication. Instead, it means that those objects are easily available to add within that Quire project. So including them in every publication is a simple matter of referencing by identifier, rather than copying across every detail manually from the CMS or wherever your data is coming from. So while we've automated away some of the time and effort involved, we haven't attempted to automate or overrule that actual processing of authorship or editing. That's still there. And of course, you can still customize how and where the object details appear, as you usually would in Quire. So this then takes us on to how we wanted to test the software out. And we asked our colleague Andrew Shapland from the Ashmolean Museum in Oxford to give the software a go. Andrew curated last year's Labyrinth exhibition at the Ashmolean, and his motivation was that he wanted to convert some of the additional institutional effort and resources that go into putting on an exhibition into some longer-lasting forms and formats. Because now the show's over, all that help, essentially from his perspective, has just disappeared. So it would also need to be something that he can do himself with the materials that were made for that exhibition. And Andrew identified multiple sources of additional documentation which accompany an exhibition and which he wanted to reuse. The first of which is the official exhibition catalogue, which wasn't written in Quire, I'm afraid. The second was the exhibition panels and labels and all of the editorial focus which went into those. And similarly, the exhibition website, again, there was lots of text that was created and edited here. And finally, there were updated and enriched collection records that went into the CMS before the exhibition and included Andrew's own research notes, which he entered into the CMS as he was preparing to keep them there for safekeeping. So Andrew decided that to repurpose this documentation, the place to do it would be into an expanded educational resources for the permanent Aegean World Gallery, where the content that was generated for the exhibition is most relevant for reuse. So armed with little more than the Quire tutorials, Andrew set to work, and you'll see in a moment here a glimpse of what he created. This is the preview of the web output from Quire, and we'll see a PDF export later on. And Andrew reports that his experience was entirely positive. I think there's a bit of a reputation that Quire has, having a command line interface and needing editing of Markdown and YAML of being complex. But Andrew sort of put it that if he can do this and find it easy to do it, anyone can. So we're pleased this has also started a conversation within the Ashmolean as to how approaches like this can be taken forward more generally in the future. So this sort of emboldened us with just enough success to try something really foolish when we thought it would be interesting to broaden our user base that little bit wider. So we wanted to support story writing by very different authors to those who would usually use Quire, and extending the idea of these education materials, we wondered whether it might be possible for school children to author their own materials. We were excited by the opportunity to introduce, at this formative age, a better understanding of what data is and the complexities it can represent, or indeed obscure. And as Saskia highlighted when opening the conference, that data isn't something we should see as perfect or fixed. Most of all, we wanted students to learn how data can inform and support their storytelling, and that these aren't separate domains or disciplines, but complementary approaches deserving of thought and interrogation in both directions. So we were pleased to partner with staff at Cheney School in Oxford from their computing and history departments, and also the museum that's actually based within the school, which is called the Rumble Museum. They have a little internal museum. And one of the things that tourists perhaps don't appreciate about Oxford is it's a fairly divided city. The east of the city has a large industrial base around a car factory, and the community at Cheney is actually really pretty diverse. The school describes itself as a true comprehensive. So the school leadership wanted us to develop a program of activities which would cross boundaries of classroom groups and subject specialisms, where students studying computing, who wouldn't usually engage with cultural institutions, did, and those studying history who wouldn't normally see themselves as having an interest in technology, would engage with that. So the form of the activities, the first activity in the program was a relatively traditional visit for the class to the Ashmolean Museum. I say relatively traditional, but it wasn't usual for most of these students. Rather remarkably, the vast majority of this class had never visited the Ashmolean, even though it's walking distance from their school. They walked in. One half of this visit was a session visit with the wonderful and very patient Andrew, who you can see there, and a deliberate part of the session was that the children filled in and created a structured record, which they'd come to use later. The second part, half of the visit, was a gallery hunt led by a member of the Ashmolean audiences team, and again using the same format for observations, but asking students to start recording stories about what they saw. A week later, the class reconvened at Cheney School for a workshop with the Rumble Museum. They undertook a parallel handling session with Rumble objects this time, and we'd liaise to identify objects that had a thematic capture, and you can see finally a version of that form they filled in on the right. And we wanted the students to appreciate the similarities and equivalences between the Ashmolean Museum and their own sort of in-school museum, because that's the one that they can own and run. Then finally, several days later, the class moved into a computing lab, and this is where we tied the museum visit and documentation into the computer science curriculum. So students were given some Ashmolean data records, pulled out of linked art using that plugin, converted into YAML, and engaged in discussion around the information impacts of the conversion and of what it means to share and standardize that information. And then they supplemented that YAML record with their own observations, which they captured from the handling sessions. They were then asked to tell their stories and encode those in Markdown, again into the Quire book. Then they used identifiers, some of which they created for themselves, to link those stories and object records to their own photos from the handling sessions. Or, exactly as it was taught to Year 10 at Cheney School, here are some learning objectives that we worked through, which are rather nice. Here is a nice, clear explanation of how we're comparing information sources that beats my own slides, and proof that all architecture diagrams should come in pastel colors to make us all feel calm. So magically, at the end, and after some fairly hair-raising debugging during the class, the children of Cheney School Year 10 History and Computing did indeed make a rather professional-looking Quire book, which the school have since published. We received some lovely and wonderful feedback, both on the museum side and on the computing side, and where the summary really was, could we have more time to do this? I think everyone was a little skeptical at the beginning that there was anything of interest in terms of those two classes that could fit together, but by the end of it, everyone was absolutely convinced. And of course, that some children who wouldn't normally make it to that museum did. So with that, I'll finish. There's a link to the website there. Thank you to all of the people who contributed to enriching exhibition stories, and all of the materials and resources that we use to run those sessions are available for reuse or adaptation on our website. Thank you.
Thank you for the opportunity to present today. I am Lynn Rother from Leuphana University in Lüneburg. Sandra van Ginhoven from the Getty Research Institute in Los Angeles will speak right after me. Fabio Mariani is not with us. He is finalizing his PhD in between jobs. We are excited to introduce the PEAR working group, Provenance Event and Archives Reconciliation. This collaborative project between Provenance Lab and Getty Provenance Index aims to reconcile structured provenance data from museum records with those of archival sources, a partnership that we hope to enhance provenance research. Provenance refers to the history of an object, documenting its change in ownership and custody over time. Most of you know, understanding provenance is crucial for restitution and authentication issues, but really for any art historical and art or historical research to art and cultural heritage. The Monet painting from the collection of the Virginia Museum of Fine Arts, which we have picked as an example, shows how museums usually record such information as free text, and, at least in the US, with a format that conveys meaning through punctuation. If we only focus on the bold part at the bottom, we see so-called collection of Siegfried Arndt, who resided in Berlin. The period after Berlin indicates for experts a gap. This means it is unclear how and when precisely the object came into the possession of the art dealer firm Knoedler, which sold it to the Virginia Museum in October of 1960. The vast majority of provenance records have significant gaps. Here, the last recorded date, for example, is circa 1910, so the gap is circa 50 years until 1960. For museums or research projects, it is rather naive to believe that all gaps could be filled at any time and all uncertainties removed. In fact, our large-scale analysis so far from museum collections has shown that the more provenance research is conducted, the more gaps and the more uncertainty and vagueness we find in the records. All the more important it is to be efficient when archival material is available to enhance our understanding of a particular provenance event. Luckily, we can turn to the GRI for provenance events involving Knoedler. The GRI holds among its many archives the records of the New York-based art dealer firm Knoedler & Co., a key player on the transatlantic art market since the mid-19th century with branches in London and Paris. Without going into the details, archival research, as most of you know, is tedious, to say the least. Without a stock number or date, as in our example, endless pages and folders need to be consulted, attribution changes, and varying titles add uncertainty to any matches. Here we show a page that we believe refers to the Monet painting in question. It is listed second from the top with 5 other paintings. We also find other details, including the names of Sophie Arndt and a Henry Perlman, which are not mentioned in our museum provenance at all. Sandra will get back to the meaning for this very provenance. What we aim to show in one example is that both the museum as a record keeper of its objects and the GRI as an information provider from its archival resources can gain new knowledge from each other. In our PEAR initiative, we want to test this on a large scale and find ways of doing it automatically. For this, we need to reconcile information across institutions by agreeing on the ontology and its specific uses. CIDOC, CRM, and linked art as an application profile are the obvious choice. CIDOC CRM follows an event-centered logic, although I've realized we use different terms, but it's about the events, event-centered, event-oriented, and we can observe the same logic for the archival material. For example, the stock book from the last slide records that a painting entered the Nödler stock at a given time, including detailed additional information on the single transaction. If museums were to write their provenances in an event-centered approach, a question would be who acquired the object at a given time, or who parted with an object at a given time. Museums, however, follow an ownership-centered approach to this day. The object was in a collection from date A to date B. The logic behind this is the museum's aim of creating a chronological record of who owned an object over time. This approach is valuable for establishing legal histories, documenting chains of ownership periods, which is essential for authentication and also for clarifying title disputes. However, it also leaves museums unable to conduct meaningful analysis of their provenance data, such as identifying gaps, let alone enhancing their records by linking to other repositories. And this is what motivated me to leave the Museum of Modern Art in New York 5 years ago and start the Provenance Lab with the funding of Volkswagen Foundation. We work with multiple data sets. Our initial project, Modern Migrants, for example, includes 5,187 provenance records of paintings from 79 US museums. To transform textual provenance information into an event-centered structured data, we developed a workflow. We use a human-in-the-loop approach, combining AI with expert oversight. With structured event-oriented museum provenance data almost available, not perfect, but almost available, we can now start to test what it means to link it to the oldest and largest historical art market repository in the world, the Getty Provenance Index, and I hand over to Sandra.
Thank you. So the Getty Provenance Index is a digital resource that provides users access to provenance information extracted from auction catalogs, archival inventories, and dealer stockbooks, such as this page from the Nödler stockbooks that Lynn already introduced. These sources document ownership or transfers of ownership of artworks roughly between the 16th and the mid-20th century. These are structured data managed in a flat file system called STAR, where the databases are siloed by document source and did not leverage the Getty vocabularies. So to enhance the GPI's accessibility and usability as a research tool, the 2.2 million records in STAR from these different source materials are being transformed into linked open data as part of a cross-departmental project at Getty, and many of my colleagues are here in this room. The auction catalogs and dealer stockbooks data will be the first to be released in April next year. The paradigmatic shift entails going from a transcription, text-based, to an event-based data model for the provenance events described in the source documents. As ontology, as Lynn mentioned too, we adopted CIDOC CRM and specifically linked art, and adopted Arches, an open source platform for managing cultural heritage data. So CIDOC CRM provides a solid foundation for both Provenance Lab and Getty Provenance Index data. Our primary focus then is on event reconciliation, that is identifying the same provenance event across datasets. An event is defined as a spatio-temporal occurrence where the involved parties affect the change in the object status. To reconcile two events as the same, we can employ three different approaches. Reconciliation by object involves comparing the titles and authors of the objects to identify matches. However, variations in naming, attribution, etc. between works can complicate the identification process. Reconciling by date leverages the temporal aspect of events using overlapping timeframes to suggest possible connections between events. And reconciliation by party examines the individuals involved in each event. So if the person transferring the object and the one receiving it are the same across both events, it indicates the potential links. We leverage unique identifiers and use Getty ULAN to help eliminate ambiguities. And we're working with Sparkle queries that combine these two source datasets, and by combining these three approaches, we can supervise and hopefully reconcile events across datasets. So through PEAR, the PEAR initiative, we aim to demonstrate how event reconciliation can effectively bridge the museum and archival perspective, enriching our understanding of provenance. In other words, in this case, by integrating Nödler archival data with museum records, we leverage the strengths of both approaches. The GPI enhances museum documentation by providing critical details such as transaction dates, sales prices, and alternative titles, information which is often missing from ownership-centered records. And conversely, museum records provide a comprehensive chronology of provenance documenting the complete or known ownership history of artworks. This integration addresses gaps in fragmented archival records and enables a more cohesive understanding of an object's journey. So if we go back to the Monet painting in this case, this reveals contradictory scenarios after event reconciliation, focusing again on the bold section on the left and the corresponding snippets of the two provenance activities described in the arches still work in progress. The museum records indicate that in 1960 they acquired this painting from Knoedler, and the painting was at some point in the collection of Siegfried Arendt. The GPI shows that Sophie Arendt sold it to Knoedler in 1958, therefore closing a gap, assuming she was a heir of Siegfried, and correcting a bias in the museum's provenance, which not uncommonly masks or erases female agency in such transactions. We also have a more precise context for this transaction. Sophie Arendt sold the painting to the Knoedler Gallery and the dealer Hendrik Perlman, together acting as joint owners. Furthermore, the dealers purchased this Monet painting as part of a group alongside 5 other Impressionist paintings, paying close to $120,000 for the half share in the case of Knoedler. And the GPI also indicates that it was in 1961 that the dealers sold it to the museum for $52,000. So to conclude, reconciling these two approaches, museum and archival perspective, allows us to fill gaps in ownership, reinstate identities, and give agency to actors involved, as well as provide details that are usually left out of museum provenance data, which are all key to reconstruct richer narratives encompassing economic, legal, and social context. And in this way, this context can also become objects of inquiry. Furthermore, the archival records become alive when we identify from museum records what the objects were, and we see for ourselves what they look like. In this manner, we can turn this transactional data back and transform it into an art historical object-based inquiry. These results fuel our ongoing discussions about the implications for provenance research of bringing together multiple perspectives and the intellectual and technical opportunities and challenges of scaling up this approach to the hundreds or thousands of cases contained in our database, in our data sets. And thank you for your attention.
Thanks. Please bear with us. I think we're the last talk for today, so after this you can get some more coffee. We'll try to keep it short and also relatively simple. We're mainly pitching an idea here that we want to build upon after this and showing some preliminary results. My name is Ruben. I work at the Dutch Cultural Heritage Agency, or as it's abbreviated in Dutch, the RCA. We work in Amersfoort. And there's my colleague Joop, who did most of the work on this pilot. So he'll talk to you through the details after this. What do we do at the Dutch Cultural Heritage Agency? I often ask this question to an audience, and they don't really know what we're doing. So I thought let's start with that. So in general, we work on the preservation, management, and the development of our national heritage. And we also work on knowledge dissemination. And in practice, that means that we work on very diverse sets of information, categorized in these categories. So archaeology is the main one. So every bureau in the Netherlands that wants to do an archaeological project, because there are building plans on the site, has to register their report at our agency, and also their findings. So we have tons of archaeological data, or at least metadata, and also the reports of these excavations. We register the Dutch national monuments. We also assign new ones, and we keep a registry of that. We have a part of the preservation task of the National Art Collection, so we have a depot in Amersfoort as well. So we have a collection management system as well. And this all generates additional knowledge. We have a library, we have an archive. We have a national heritage laboratory where we do tests and experiments on artworks. So basically, we are kind of a Dutch digital heritage landscape in small, which is why our use case is perhaps a bit difficult, because we are trying to do many things at once with data. So we originate from a very diverse group of organizations that precedes the RCE, which means that our IT landscapes kind of look like this, with all the arrows and dots, and I still can't figure out what happens where. So basically, we have different sets of information, and they're all related to each other, perhaps, but we don't know. So when I came to work at the RCE a couple of years ago, I asked the question, where can I find all information about this church? And we couldn't really answer that question, because it was stored in different silos, with different kind of data models, different kind of metadata. So we couldn't really answer that question. We still really can't, but we're working towards answering this question. Because we have lots of experts in our agency, so we know the relations between the data, but the end user can't really get that answer himself or herself. And Joop knows much better, so I'll give the floor to him for now.
I try. Thank you very much, Ruben. I'm standing on the shoulder of giants here. This picture was made about 8 years ago by our information architect then. That he used this to tell our management that we needed linked data. That was, we have a church in Elst. Under that church is a Roman temple. We have pictures of that church, other finds in there, and in the church is an organ that's also protected by our protection law. So we needed, and he used this to tell, hey, we need data. There are links between all that data, and we have to make them explicit. We have to make an ontology, and then we can answer questions that people have over all those collections. It took a few years, but in 2018 we took our first steps with linked open data. There were some projects before, but those things only worked on my laptop or the laptop of my colleague. And when the laptop broke, all the work was gone. But this is where we are now. We have our own linked data, linked data voorziening, as we call it. And you can visit there. And in the linked data, we put some data, put the data of what Ruben mentioned, but our data we have to collect by law. That's archaeology, the national monuments, the Stads- en Dorpsgezichten, and the World Heritage Sites. For that, we made our own CEO ontology, because we couldn't find an ontology that matches all the knowledge we had to express in an ontology. Also, the library data is in there, and the image database is in there. The library I modeled with schema.org, because I didn't have much time and it looked simple. And image database, that was a time when I had much time on my hands. That was during COVID, so I used linked art. As you can see, we have 3 or 4 different ontologies to match data and to unify the data. So, Ruben, up to you again.
So then we thought, that's nice, now we have linked data. Let's query it all at once. Didn't really work, because we have different ontologies, we have our own ontology. We have it in different graphs, different databases in our application. So that means if we want to query it, we either get a timeout or we don't know ourselves how to query it. So we still haven't really solved our use case that says provide me with everything about a national monument. Still difficult. So that's why we're working towards building a knowledge graph centered around national monuments and archaeology as the main concepts. So the steps we want to work on are, use the linked open data we already have, consolidate it into a new cohesive framework using one endpoint, and remodel the data sets, because we think if we want to have a good experience for the end user, we have to make it more simple and always redirect to the source data, but make it possible for, well, the average user to answer questions. And we thought, I hardly dare say it here, but we tried to use schema.org to model it too. And we don't really know whether that works yet, but we'll find out. And we try to improve the use of thesauri and vocabulary and control terms, of course, to make more connections to our data and also to other data. And we use Sparkle constructs queries, of course. A thing I've seen coming across more often this week, so that's nice. So that's basically what we do. We use the cultural heritage thesauri, kind of the Dutch part of the art and architecture thesauri. We have a base register thesaurus, RKD artist, that we use as terms to interconnect the data. And we do some extra named entity recognition to get more control terms into our data. And some of the things we want to be able to do, I'll give that to Joop for the final bit, the most impressive part, which we hopefully can build upon. Still a pilot.
I start with, I'm sorry, I had appointments here this week, Monday, Tuesday, but I was working on this. I couldn't get it working beforehand, so it cost a lot of time. I wrote some construct queries, and one rule is don't show a Sparkle query to your audience. So I won't do that. I just show the result of the query. The red one is the church in Elst. And the green part, you see that's the archaeology, the Roman temple, and the finds my colleagues, found under the church. That I did it with the GeoSparkle features overlaps. I added the data about the archaeological finds, the textual data. That's why we need named entity recognition, but because there's a lot more information in those texts than we have in the fields in our data set. And that's the last part, the built monument, the literature, so a book in the library about the organ in the church, and a reference to our image database where you can find more than one picture of this. This is I think I used max, so I all got the war damaged church, because I didn't want to use sample, because that perhaps we were looking at a churchyard or something. That's the query. That's where we stand now. So you can scan the QR code and look at our work. Don't shoot the messenger. We're still working on it. Not this year anymore. I think we picked this up in January. Thank you on behalf of Ruben. Thank you very much.
So, as before, we have a moment for some questions and some answers. The scheduled amount of time we have for Q&A in the program is going to be adjusted slightly. We're going to bring forward some farewells and some housekeeping to do before the AGM and before coffee. So if everyone would like to come and join me, I've been given some choreography.
Order.
Not everyone.
Order.
If all the speakers would like to come and join me.
Where you want us?
1.5 meters in front of the screen, and we can file off this way. Thank you so much for being so super prompt. We've got loads of time, so I'm going to look for hands sticking up for questions, which I'm waiting for. Microphones will be coming down from the corner. Okay, already we have one. Is it Liz, maybe? Yes.
Great work from all of you. This is a great afternoon. I wanted to zero in on the kids. Yeah, you knew the first class was going to be about the kids, and with the project with you, Kevin, and just like I didn't get a chance to like read all of the testimonials, but so if you could just like. What do you, because they did some documentation, they actually did publishing, they did metadata. What do you like? What were the main takeaways that you feel like, or in the end, was it that they actually figured out how to do quick, close looking at a museum. Anyway, I just want to hear about it because I thought it was just a great project.
Yeah, it's a great question. I think the answer is we could do more of all of those, and everyone involved would see the value in doing that. And that would interest people. So yes, they both had a sort of traditional museum study. One of the things we're going to try and nudge our colleagues in the museum towards is whether that could actually become part of their educational program, to do this engagement with record keeping and with digital tooling, because at the moment it absolutely isn't. But yeah, there's potentially something that might interest people in this room that I think the education team there now sort of went, yeah, once we got to the end and they saw it working, they had no idea until the end. Because it wasn't obvious. I think that was one of the parts, is actually until people had seen it come together and seen how having, you know, the bolded keyword on the recording sheet and that becoming part of the key value pair that went into the data, people just hadn't joined it together in their own heads, let alone seeing the children do it. But of course the kids just go ahead and do it. They don't think anything of it. It all makes sense to them, which was great.
Okay, Chris.
Hi, thank you all for the really great presentations. I have a question for Rob and Kelly. And I think, so one of the things that we were seeing while doing the reconciliation ourselves is that after a while you can also hold it against the Wikidata alignments and see whether you find inconsistencies in your own alignments. I was very curious whether, so I'm saying actually the moderator of your session has been doing that, but my question maybe to you is, did you do the same thing, and how did you handle the outcomes of that, and did you start addressing with improvements?
Yeah, shall I take it past you?
Yeah.
So yes, we find all over the place errors with the graph of connected records. You know, it could be that some bit of code that someone wrote that generates the entries in Wikidata was slightly wrong, or you know, some person just looked and read the label and didn't go into the details and just made a poor choice of equivalencies. So when it's our records at fault, you know, we don't have a system of record and lux, so we feed it back to our units, right? And we can say, here's a problem, please go and fix it. In Wikidata, we can edit it ourselves, of course. Whether or not it persists is up to whether, you know, that script reruns and it gets overwritten. But
yeah, I think it was in the diagram, but I didn't talk about it, but there was a thing that said URI indexes, where we have some separate spreadsheets that are being called on during that process, where I can manually either force a detangle or force a tangle, with a different from and a same as index that get built from a Google spreadsheet. Yep. And I've even somewhat automated the process now that if I have a Lux record that's clearly been over-merged, as we would say, I can enter it into, I built a little app that I can just drop the link in there. It'll tell me all of the possible records that are building into it and what they are. And usually that's sufficient. It's still like a very manual process, even at that point, because a large Lux record might have 60 or more contributing records, and it takes me quite a lot of time to do detangling. But then I can click a little button, automatically add them into the index, and it, you know, to make it as quick and easy as possible. But this is a major an area of like research and concern for us. And I think what it comes down to, my exact is not your exact, and it's not anyone else's exact, and there needs to be a conversation about what that means when we use the properties.
Good, thank you. A side note there, so we've been mulling about that logic of when is something the same thing and how fast are you stating that. We have been mulling that over for quite a long time. So maybe if we all start sharing that logic, we can sort of hold it against each other and then inspire other people as well. So that would be great.
Yeah.
I don't want to have to pick on people. Helene.
Okay, then I take the liberty of asking two questions to different people. To the Dutch team, a technical question for like what you're building now. I was wondering, did I interpret it correctly that you're using both linked art and then the schema.org on top of it?
Yeah, so the vision now is that we keep the source linked data in its domain model. So that could be linked art for the collection, our own cultural heritage ontology for the archaeological data and the national monuments. But connecting those in one knowledge graph without doing something to the data model is difficult. So we thought, let's try to use schema.org because that's one of the recommendations of the Dutch Digital Heritage Network, and see whether we can make that fit. We're still not sure whether that works, but it's a nice experiment to do so.
Thank you. And a provenance question as well. Some years ago, I have been doing a little bit of provenance in different museum collections, and I noticed, at least for Egyptology, that the word or the terminology is used in many different ways. Like, for example, it was excavated here in Egypt, or we think it should have been from Luxor, but we don't know, or more the information that you're showing. Is that something that you come across as well? And I can imagine if you want to combine the knowledge not from your collection but the other data sources coming available, that it's an issue?
Yes, we
Huge issue.
Yes. We're aware of these issues of terminology, and definitely our experiments, or beginning of these experiments, have sparked this acknowledgement of a need to, bring together cross-disciplinary teams, including legal experts, for example, for some more technical terminology, and decide on the terms that we might want to use and in which context, and particularly in an event-based, I think.
Yesterday, the AAM, New Horizon, so the American Association of Museums, has this New Horizon papers where I argue for common language and provenance. And common language it doesn't mean that every museum has the same legal understanding of what is looted, but that we mean the same thing, what looting means. And the same comes with CIDOC CIM. So, having now provenance data from 79 US museums who all follow the so-called AAM format, there is no consistency how the very same auction in Paris is described. So yes, it's a massive, and that's really the work of the provenance community that can, with the Getty vocabularies, where our friends hopefully get a better understanding so that we can actually link this across.
Thank you.
Lynn, you also have a question.
Can I have a question to Nicola?
Should we all stand and switch?
I'm first because it's connected with this question. So did you try to use a large language model to try to extract structure from the provenance text? And
yes, it's a nightmare.
Okay.
So far, no, we have used, we did the training AI with training our algorithms on a third of, for example, all provenance text from the Art Institute of Chicago, and then using it. The results are almost an F1 score. Large language models, not yet. And Fabio has, I'm not sure if he's publishing on it or not, but he has it readjusted the prompts constantly, etc. So far, definitely for when the provenances come from multiple sources.
Yeah.
And yes, and because you have this complex linguistic plans. I have a question for the exhibitions. When you have in all the participants in exhibitions, you also have lenders. Often we actually don't know who was the lender of a particular object, but we do know from the catalog, because, for example, the exhibition records are destroyed. But we do know from the catalog that these were the lenders, including anonymous lenders, for all the works. Yeah. So do you then anticipate and create uncertainty because every lender is a possible lender for every object in that exhibition. How do you account for that? Linked art, I think, stops there, right? So that's why we add
I have another exhibition, another pair of slides that talk about how do we practically model there's no time, but how do we practically model that uncertainty also in between, because I was doing it not in the term of with the lender, but in term of somehow where people are, because we have address sometimes, but it doesn't mean that they stay in the same place, people move over time. So how can we take into account and then compute with an interval algebra the possible location of one person in between record of address? And I try to model that with uncertainty. I didn't present it because it's not definitive, but technically there is something out there, but there is nothing shared. It's it's possible to just build up on some ontology on it and just classify certain period or just create a custom one. And in my case, I'm doing custom and then define it more on the data side.
If there's no other audience questions. Right, did I want to jump in on this? So,
sorry guys.
We need chairs and have a panel. Anyway, one thing that we have done in Linked Art and with Oxford in the previous exhibition work is a Linked Art pattern for exhibitions, which is very, very similar to what you have. So great, it's going to be easily compatible. One approach to the issue of lenders, but also for exhibitions around a particular artist, where we don't know that photograph was created by artist or painting was created by artist, is to have another node, which is the sort of work for the exhibition, and then associate the people that we can't relate directly with the work. It also allows you to have subjects for the exhibition, right? The exhibition has a subject of peace or conflict or et cetera, right? Which you can't associate a subject with an activity directly. So that was our escape route for those kinds of things.
If I may, I'm testing also the possibility of, well, I mean, in a RDF right now, it's a bit more complicated. In a RDF star, it's doable, but to actually use some kind of formal reification in order to assign a property of uncertainty with respect to specific relationship, it's definitely easier to do it with property graph. That is fantastic. But using a RDF star is possible, although there are not so many mapper and there is a lot of problem with the RDF 1.2. But let's not dive into that. But technically, there may be a possible solution too. It's probably worth from a data standpoint to look at, but ontologically,
Just like to give the floor one final opportunity to raise a hand. Otherwise, I will welcome Saskia to come and close things up. Saskia, please join us.